looked at it as lights, so that's a one-time,
Yeah, yeah.
you know,
Yep. Yep.
no, we're using Cat 6 cable, we're not using
Right. Right.
Romex,
Right. Right. That's interesting.
14 gauge Romex.
Right.
So we're getting there.
Yeah. Excellent. Very cool.
Same game plan, right?
Yep.
Okay. Ooh. Yeah. Yep.
Yep. This is how take care of it. Just the mic's on.
Yeah.
There was a member back there in the Army that he was in 1990, which is the initial defense memorandum for decision consolidated agreement. It's taken a long time.
Consolidation is probably
Not the right term anymore, but at the time, that's what it was.
Yeah, I can help you.
Everybody had to do all this.
Oh, I don't know about the follow-on presentations. I'm not sure. No, they. Gary's from our team right there. Gary's our new Army account. Yep. 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 Yeah, I just recognize that. Yeah. Very hot.
all your deep faults.
So good morning. This sounds like it's working okay. My name is Denny Moen. I'm a member of the local FCA chapter here at Fort Gordon, one that I actually joined in 1969. Maybe I'm the oldest FCA member present, but I'm honored today actually to be the moderator all day in this room, for all the sessions in this room, so you'll see me again. This meeting is actually, this work talk is about transforming DCO. It is a panel, and I'm not going to talk or introduce the panel. They're going to do that themselves. This particular hour has been approved for 1 CPE. I have a scanner. If you're not familiar with what that means, you need to see me before you leave the room, and I will scan your badge. And if you're a member of FCA, you will automatically get an email from FCA with the credit. If you're not a member of FCA and did sign up for the CP credit, I don't know how that registration works, but you may need to visit FCA booth 123 and take the opportunity to sign up to be a member of FCA. As I said, this is going to be a moderated panel session, and so I'm going to turn this over to Dwayne Shugars. He's the Vice President Operations of Macaulay, Brown, and Enlighten IT Consulting, and so he gets his time. Thank you very much. Don't forget at the end, I'm going to remind you, see me.
For that credit, you're going to need to take a test at the end of this, so it's all good. You all right? All right, well, welcome. Good morning. I don't know how many of you had to fly down the East Coast or up and down the East Coast yesterday, but we all made it, I think. Still jet lagged, even from a 2-hour flight. I don't know how that's possible. Anyway, this is what we're going to talk about today. If this is why you came, you're in the right place. We have a lot to cover. All I ask is hold your questions to later, because virtually every slide in here can turn into a rabbit hole of questions. And they're all good questions, but we only have an hour. So if you can hold those to the last part of this, I'm going to try to get through sort of a background, context, lessons learned of everything we've been doing with the community, and then the panel will take over from there. So with that, I'm Dwayne Shugars. I was already sort of introduced, so I'll let the panel introduce themselves, and we'll get that out of the way so that when we come back to them, we'll just get right into the meat of things.
Good morning. My name is Sean Justice. I'm the Senior Vice President and General Manager of Macaulay Brown's Enlighten IT Consulting Group.
Yeah, and I'm Jim Caggy. I've been managing the DoD National Security Team for Amazon Web Services for the last 4 years. So I lead all of our DoD security operations work, and I've been working in both the intelligence community and DoD for over 15 years. Spent 12 years as an Army infantry officer.
I'm Tim Israel. I'm the Director of Cloud Engineering for Macaulay Brown's Enlighten IT Consulting. I work very closely with Amazon and Jim specifically to help merge our DoD and cloud engineering goals.
All right, with that, let's get started. The sort of flow of this is going to be many of us who have played in this space for more than a year, like 8 to 10 years, working across DoD and the IC, probably are going to very sort of nod their head in the affirmative of most of these DCO challenges that we'll present. But again, we're going to use that as a backdrop for what we did with the community, how the community sort of met some of those challenges, and then where do we believe the community can go using some of these commercial cloud infrastructure components. We will profile 2 use cases, one Army cyber use case, Army cyber use case, and then a US Cybercom use case. Good news, we've got 2 people in the room that are very familiar with a lot of that, so from the government perspective, so they'll be able to add that flavor. And then the lessons learned out of the last 4 years or so, if you add the IC portion, the last 8, and how can we now use what's readily available in the commercial cloud infrastructure, secure cloud infrastructure, to really move this DCO, I don't want to say war, but the war on cyber forward, because we've been doing this for quite some time, and it doesn't appear we appear that the cyber attacks are increasing by dramatic paces, and the complexity of cyber attacks are also increasing, but we haven't really been able to sort of propagate a complete in-depth defense strategy, and hopefully some of this will be at least the discussion points of how maybe we can move forward as a community. If you guys, most of you have been in the DoD for a while, it is one of the most common divergent network infrastructure on the globe. It's network upon network upon network upon network upon network, all the way from tier 1, which is sort of the DISA.mil network, all the way down to tier 7, which is sort of your computer on a local area network. All the services have built their own infrastructure along the way because they had to. You know, DISA's built their infrastructure, and these infrastructures just sort of build on top of one another. And over decades and decades, these things have become very complicated to understand. So how do you defend something that you don't understand? We would be sort of at least comforted to know that the adversaries, because it is so not understandable to us, that they wouldn't understand how to attack it. But all they have to do is sort of get one into our network, and that could be catastrophic. So the point here is we've got to figure out a way to simplify some of these challenges. JRSS, to the Joint Regional Security Stack, which we'll hear moans or hoorays, depends on what side of the you are on that, but that is supposedly going to sort of regionalize a lot of the tier 2 infrastructure, and so that is a good step in the direction of sort of building that infrastructure. Data acquisition, again, as long as we've been doing this, the thing I hear constantly is data is going to be the long pole in the tent, and so in order to sort of attack this DCO challenge, we need to get better at getting data. And that means a lot of things. One, we're limited across the board in people's politics, meaning I own my data, I'm not going to give you my data. You have the authority to see the data I'm going to give you. And then second or third to that is how do we get the data from point A to point B, given bullet number 1, is firewalls, putting holes in firewalls, and by the time you do all that, you don't get data. And so this challenge is real, and we can't expect to actually be able to see what our adversary is doing if we don't get the data to the places it needs to get. And then bandwidth, those same infrastructure challenges, as more and more mission sets are getting distributed across this DoD infrastructure to support UAVs and all the other very high bandwidth intensive missions, it gives less and less data for us, or less and less bandwidth for us to get this kind of data to a place that we can analyze it. Accredited scalable analytic platform. The good news here is from lessons learned both on the IC side and the Army side, there's a big data platform that is built, and the next slide will sort of give you an overview of what that looks like. That has actually emerged over the last 4 years to be something actually that can scale to the volume velocity needs of cyber. It's accredited, and that's always a good thing, and it also understands this notion of distributed queries and distributed authorities. Why is that important? Because as you propagate all these different data sets, again, some people want to own their own data or at least have control of their own data. How do you make sure when you're ingesting that data it's controlled at a level, cell level, so that we can then disseminate based upon your authorities? So all those things are built in this platform, and again, we'll talk about them in the next slide. Data sharing, this has been a problem for quite some time, and we've made some strides in sort of working this challenge, but at the end of the day, we're still doing swivel chair DCO. I'm down on Nipper, I'm on one computer, I have to then go to SIPR to do something on SIPR, and then if I want to get up to JWICS, I'm writing things down, I'm sending things through a single file transfer. It's just not the way we have to sort of approach this. And so really a better way of sharing data, aggregating data, not just from the low side, but all the way up to the high side, and we'll talk about some of those efforts. And then a DCO strategy, what we've seen and what has been done over the last couple of years at least is we've been approaching the DCO at the level, sphere of influence that we're in. If we're down at the services level, we're dealing with it there. If we're at the JRSS level, we're dealing with it there. If DISA is doing it, they're doing it at their level. I go out to DISA Global and I tell the analysts, have you talked to Army cyber analysts? Have you talked to the cybercom analyst on this mission? No, we have a very, very specific vector that we have to look at. We're not interested in that. There's absolutely no way as an attack vectors and goes through all 7 tiers that if we're not talking that we're going to necessarily ever see how that thing got into the network and how it ultimately propagated. So having a strategy of saying we have to look at this holistically across the community, I know that's dreaming a little bit, but I think in the next 2 slides that we show you, or at least the 2 slides after the next, you'll see how the community actually came together to meet some of these challenges. This is, and again, this could be an hour presentation in itself. What you need to know about the Big Data Platform, it is a third-generation platform built all on open, well, 99% on open source technologies, and a whole bunch of lessons learned from Army INSCOM, one of our IC partners, and some of the things that DISA did in the late 2012-2013 time period. Our goal here when we built this for DISA, it is controlled and ATO'd at RMF level by DISA. It just got its RMF ATO in the last couple weeks. All this is free to the government, so any government organization gets to utilize this platform. And our goal was to keep it sort of free, as open source as possible, because Silicon Valley supposedly has the answer to a lot of our problems. And if we're at least able to inject some of their technology, infuse it, and build it around and integrate it in a way that actually meets some of our specific needs in DoD, then we'll do a pretty good shot at being able to support the DCO mission. We are talking specifically DCO, but big data is data agnostic and mission agnostic, so everything we're talking about today could really be infused with EW and other types of data sets, and ultimately all those could come together in one nice way downstream. So again, you can come to our booth 314 if you want to get detailed discussions on this platform, and you can also Google it. There's plenty of stuff out there on the web. Again, baseline controlled by DISA, but it has been a community effort, sort of the community of the willing, and we'll talk about two of those use cases of how mission partners have contributed to this platform to evolve it in a very rapid pace. The two use cases we're going to talk about today, basically an evolution over the last 4 years or 3 years with the Army Cyber, and their use and their contribution to the BDP and this whole DCO sort of migration into the commercial cloud. And we'll also talk about a very specific cybercom use case that we did in the last 4 to 5 months that sort of at least speaks to the things that we'll ultimately talk about, the ability to do these things very rapidly in a commercial cloud infrastructure. So these will be done in a very timeline view, and I'm fortunate to have Colonel Stanton in the room because under the Army PEOEIS, Army Cyber effort, Colonel Stanton went to DISA. Look, we know you're building a BDP, this big data platform. Army INSCOM has built some stuff around Red Disk and for Red Disk, and we've learned lots of lessons. How do we come together as a community and build a platform that can sustain the needs of the DCO mission? And so under the big data ONS out of the Army, the initial pilot was a 6-month pilot to prove some integration points of some of these other technologies. That pilot was successful, and after that pilot, another 6-month pilot. And so those pilots have evolved over the last 2.5, 3 years, and each of those pilots have ultimately integrated new things into this platform. The thing to keep in mind is the BDP is in a government open source platform. We have over 1,200 developers inside DISA's DevForce community developing analytics, parsers, and things to the BDP. And so the Army was the lead, the Army Cyber was the lead of building some of these initial capabilities into the BDP. Somewhere in the 2015 timeframe, after the platform got to a place where it could sustain the volume velocity of the data we were talking about, we were able to get an IATO, and again, this required a very senior level involvement to get an IATO to put BDP into Amazon for the Army Cyber. Army Cyber called it Gabriel Nimbus, so when you hear Gabriel Nimbus, just know that's also the BDP underlining it, but it's the way that the Army Cyber has been using the platform. We were able to actually get an ArcSight connector from a place in the Army infrastructure, so we were actually able to start aggregating all the ArcSight data out of ArcSight into Amazon GovCloud through an encrypted link. And so this was now getting all that aggregation of ArcSight data in a single place where now we could build analytics, run analytics, and do collaboration. So at that point, we were running at about 40 different data sources, and this is sort of the first example of using commercial cloud gets you access to data faster. We've been at DISA for almost 4 years, and on NIPR, we've gotten 12 data sources. That's 4 years. In less than 3 months, they were able to get 40 data sources coming out of ArcSight into this commercial cloud because they didn't have to deal with all the politics of firewalls and how do we get through the infrastructure to get the data to a certain place. They built an encryption link. They took what the system they had as an aggregator and just pushed the data into Amazon. One of the other things we started seeing is the volume of the data. we were funded under one of the same pilots to prove that this platform could scale. So using Amazon infrastructure, we were able to scale performance tests from 20 nodes to 40 nodes to 50 nodes to 100 nodes to 200 nodes. And all along the way, as we did that, we also optimized the platform. We built better things along the way. And so we went from, after that document was published, and it was published to the community. So basically, the Army said, community, if you have a BDP, you want to optimize it, you have 50 nodes, here's how you should configure it. If you have 100 nodes, here's how you should configure it. Never been done before. Nothing at scale like this was ever done before. And we were able to do that over a 2-week period in Amazon, scaling from 20 to 50 to 100 to 200. And so again, just the ability to sort of at scale test and then ultimately optimize based upon those findings was one of the first value propositions we saw inside of Amazon. One of the things that I think we're most proud of is the fact that the Army cyber folks led an effort to bring some of their ORSAs, some of their data scientists onto the program and start taking some of their math knowledge and some of their knowledge of these data sources and start building R algorithms. R is the statistical modeling language. They were able to build those algorithms and very quickly and rapidly convert those into Spark jobs into the platform so that they actually were able to build analytics. So the ORSAs were actually building the analytics. We weren't building the analytics. They were building the analytics. They were deploying those analytics. And there's, I think, a 190-page white paper on all the things that they were able to do with those analytics, with those data sets that were already in Gabriel Nimbus. So again, we can point you to the government POCs for all these things. But just know there are a lot of lessons learned, a lot of good behavioral analytics, a lot of interesting things done on those data sets that were in Amazon GovCloud. More recently, as we progressed, one of the things that the Army said is we're going to deploy, if we deploy these things geographically, and JRSS is ultimately going to deploy BDPs geographically, how are we going to distribute these queries? How are we going to be able to do a query from one BDP to all these other BDPs? It's a very complicated problem, not just because it's not technically challenging as much as it's how do you pass those authorities across the infrastructure? So if I log into one system, how does all the other systems know who I am? You need a centralized authentication device, which we don't, or authorities that we don't really have. So it becomes a very complicated challenge, but the Army went ahead and developed it, and they've basically committed it back into the DISA BDP governance process to be included in the next release of the BDP. So that's actually the first successful example of distributed query and distributed analytics on the BDP. Because of all these successes, we were, actually we weren't, but the Army Cyber ORSAs went globally to all the RCCs and said, because they were told to go to all the RCCs and said, give us your data. So this is that first thing about having senior leadership involved. They actually physically went to those folks and said, you're going to give us your data, and you're going to basically connect to this IP address, you're going to encrypt it, and you're going to send it into this S3 bucket inside of Amazon. So in the last 2 months, huge strides. We got the top priority feeds from every RCC in the Army going into the Gabriel Nimbus. So now you have all that ArcSight aggregated data, you have all the RCC aggregated data all into one platform, over 120 data sets now in Gabriel Nimbus. And again, DISA is at 14, and that's not a statement of DISA necessarily, but just knowing how difficult it is when you're working within the infrastructure of DoD to get access to these data sets. And so now we're in 2017, and once you have the platform, you have the data, and the data being the key there, but having a platform that has APIs and SDKs, all those things to build analytics easy. We were tasked under a C5 consortium to build a 6-month pilot for a continuous monitoring risk scoring, which I know we've all been trying to do that for quite some time. It's usually always fails because you don't have access to the data. When you're trying to do risk scoring and you don't have the right ACAS or HBSS data, your scoring is not going to work. So in less than 6 months, we built a prototype, which then was presented into the Army Cyber folks, and they basically said, now that we have all the RCC data, we have ACAS data, we have HBSS data, we have this data, could you productionalize this prototype? And in less than, I think, 3 weeks, we now have it sitting in Gabriel Nimbus, ingesting some of these data, doing some of the scoring. It's not where it needs to be, but it's sort of the idea of how fast you can do things. When you have the data, you have the platform, you have the infrastructure ready and available. And so the other interesting thing about this, up until this point, Gabriel Nimbus was about 50 nodes, 50 servers in Amazon. We're now scaling to 80 to 100 to meet the needs of those RCCs. Very easy to do in Amazon. We just add instances. We know exactly what the cost is going to be, so we can give the Army the cost. And we'll be able to do that without having to go out, procure hardware, procure infrastructure, find power, space, and cooling, you know, all those kinds of things. I got a little ahead of myself. So anyway, all of that sort of meets the data acquisition. We bypassed a lot of that DoD complexity and infrastructure. Data sharing got a little bit better because now the RCCs are talking to one another in a platform that actually is sort of, I'm not going to say unified because that's overstating it, but in a centralized platform. So there's a lot of those key infrastructure lessons learned that we gained out of this, and again, this will feed ultimately our next presentation. The next use case is a quick reaction requirement that came out of US Cybercom. Basically came to the CDG and Cybercom and said, we have to go someplace and make sure our networks are secure, and we're going to keep it at that. We have to deploy teams all around the globe. All those teams are coming from different services, have different kits, maybe not all be able to talk to one another. How can we get all this data into a platform in a place where the analysts can actually run analytics as well as collaborate? And so in less than a week, we deployed 4 instances of the BDP into Amazon. And again, this is the beauty of Amazon. We spun up the instances, we deployed the BDP in it, and now you have a test, a dev, a training, and a production environment sitting inside of Amazon. Working with Amazon, we also were asked to be able to send these 100 terabyte storage devices with these teams so that they could pull the PCAP off the network, put them on these 100 terabyte storage devices, and then ship them back to Amazon so that they could be ingested into the BDP. There's a lot of details behind all this, and again, these are all fairly detailed descriptions if we ever wanted to do it. Deployed 40 parsers and community analytics. Because the BDP is this platform that the community, 1,200 developers have actually developed parsers and analytics, not every single one of them. We were able to actually take out of that environment parsers for the data sets that were coming in from the Cybercom Pro off of the PCAP. We're able to take existing analytics, many of the ones that Army Cyber built for the behavioral analytics, all deployed those on top of the data sets coming off of these collections. So did they have to be tweaked? Yes. Did they have to be modified a little bit because data sets are always a little bit different? Yes. But the reality is we're able to deploy that many things, BDP, send snowballs out, and have parsers and analytics deployed in less than a week. It's ridiculous. At least it gives me goosebumps. Anyway, one of the other things we were able to do is DARPA has a PCAP processing tool that they use to extract all that metadata out of PCAP. We took that and actually ported it into the Amazon environment and distributed it, so now we could process at scale all that PCAP that was going to be dropped in off of these storage devices. So again, we built out a whole nother separate Amazon infrastructure to do just that PCAP processing, and all that metadata got shoved into the BDP with the notion of being able to get back to the PCAP if you need it. This is the other one that sort of blew my mind is Cybercom, basically in less than 2 weeks, Melissa, along with our team and some other folks up there, were able to actually get a full ATO, a 6-month, or I think it was a 6-month ATO the first time, a 6-month ATO for this environment inside of Amazon GovCloud using reciprocity from Amazon because they're level 4 accredited, as well as DISA's BDP, which is RMF accredited. So those 2 accreditations allowed the DAA for Cybercom to basically go ahead and say, we feel comfortable taking the risk to put this data and this mission inside of Amazon GovCloud. The mission execution means we actually had analysts actually sharing data, looking for things inside the BDP, communicating with the teams out in the field on a daily basis, many times, multiple times a day. And we were able to go from sort of nothing to mission contribution in less than a couple weeks. All right. So we've been sending these storage devices out over the last 6 months and been getting them back, and we keep getting lots of this stuff back. And so we've, at this point, put about 30 different data sources, mostly Bro data sources, 400 terabytes of PCAP and 40 terabytes of metadata. Not huge, but for this mission, extremely important, because why? Most of these teams, after about a week or 2 weeks, all that data falls off their kit because they just don't have a place to store it. Now we have the last 4 months, 5 months of this mission all in a place, preserved, to allow us not only to analyze it for today, but also as we go on new missions to be able to go back and look at things that might have occurred on this mission for future-based missions. And then the good news about this is we had multiple teams collaborating, sharing leads inside this environment, pushing those leads up to the high side, to Cybercom. And all this was being done within this ecosystem. So again, a lot of awesome things occurred in a very short period of time, all off the sort of the stuff that we did with Army and PEOIS on Gabriel Nimbus. All those lessons learned from there got transferred over to here, and you see the pace at which we could do things based upon that lesson learned. So what does that all mean? The lessons learned. So having an accredited out-of-bound cloud infrastructure became extremely useful for us because we're sort of bypass a lot of those challenges that we said in the first couple slides, and we're able to deploy compute, storage, processing, all on an accredited platform, and we were able to do it pretty quickly. In less than a week, deploy 4 big data platforms. In less than 2 weeks, get data flowing into it. All those things actually give us sort of hope that if we look at things maybe a little bit different, that we could actually make some significant strides in some of these cyber attacks. And then one of the things that we've been pushed more recently by Colonel Stanton is how do we get some of these analytics to be more localized to the team? When the team goes out and gets deployed, how can we pull some of those analytics into the environment that the teams are operating out of? Because a lot of these times the teams go in, they don't know exactly what they're looking for. They're sort of surveying and figuring out what's going on. If we could run analytics, the same analytics that we're running at the higher tier, but in a localized fashion, we can now start popping leads up for the analysts when they actually get deployed. And Colonel Stanton probably could give us all a fairly good dissertation on exactly how to do that and what's the best way to do that. So out-of-band data acquisition, I think it's pretty evident. If we're not working within the DoD's infrastructure to get data from point A to point B, all RCCs through the DoD network to get it to some other place would have taken us probably never. We were able to go RCCs into Amazon, RCCs into Amazon, RCCs into Amazon, and that direct connection was able to get us to bypass a lot of those challenges. Not saying we shouldn't figure out a way to work through those challenges, but for now, this is the things we need to do to meet this mission. Commercial cloud, I think we've talked about all these different elements of commercial cloud, so we'll hit the next slide. We would not, this has never been a technology challenge. I mean, yeah, technology, a lot of the technologies are sophisticated and you need to know how to integrate them to meet the challenges of the DoD, but this has always been about how can we be successful? We need senior level involvement. Colonel Stanton was the colonel that went to DISA and said, this is what we need to do. He's been leading the charge through Cybercom and now down here at Fort Gordon to say, this is the vision, this is where we should go as a community, not as just Army or Army Cyber, but how do we do this at a holistic kind of way? And that kind of leadership, General Cardone and many others now sort of pushing us into the place where we actually are getting the types of sort of backing that is needed to do these kinds of things. Yes, it's perceived as risky to put data in a commercial cloud infrastructure, but if you're on NIPR and you're doing cyber defense now, you know that NIPR is not that secure either, so we need to just figure out a way that we can ultimately keep these two things at a risk level that everyone can accept. Scalability, compute, memory, we talked about all that. And then ultimately being able to get the metadata, instead of sending that 100 terabyte storage device out to the field and wait 2 weeks for it to be shipped back to Amazon to be ingested, how do we do some of that initial processing up front and send just the metadata across the network, because it's smaller than the PCAP itself, to the centralized multi-tier correlation environment? One of the things we're able to do manually is correlate a lot of these findings, or at least a lot of the collection from the CPT with Tier 1 DISA, because they have a BDP, so we did a search on DISA's BDP, we did a search on Gabriel Nimbus, and we did a search on the Cybercom system for the same occurrence. And of course, you see it in all of those. And so that's where that distributed query is going to come in handy. When you can query across one time and get across all those environments, you can now start giving context to the CPTs collect, or any of the teams that are out there. And then a more holistic DCO strategy, Cybercom, CDG, sort of leading the charge along with Colonel Stanton to sort of guide us into where should we go for sort of approaching some of these challenges. So I think I did that in 20 minutes. So I know it was really fast, but again, I'm going to let the panel take over from here, and what we're going to talk about is sort of all those lessons learned, what's within the realm of reality, not in years, but in months, and then what would that look like, and how could we actually meet some of these challenges and adhere to some of those lessons learned?
Yeah, so I think So I'll just kick off, talk about some of the current Amazon infrastructure, and then some lessons learned we had during the mission, and how we're improving our infrastructure footprint and services footprint over the next few months. So number one, we've been deploying, obviously Amazon Web Services, we've had 16 geographic regions where we deploy web services or cloud services across the globe. Within the United States, we've had 5 commercial regions, and then we have several government-focused regions where we deploy the same exact commercial capabilities that we have for the government at certain accreditation levels. So starting about 4 years ago, we accredited all of the Amazon United States infrastructure under the FedRAMP and DoD Cloud SRG regime. Most recently, Amazon GovCloud achieved DoD Impact Level 4 and Impact Level 5 status, so that allowed us to host unclassified national security systems inside of the cloud. In parallel with that, 3 years ago, our intelligence community program kicked off under a contract called C2S. So C2S allowed us 3 years ago to deploy a TSSCI accredited Amazon region. Again, it's the exact same commercial services that we offer all of our millions of customers worldwide, but we offered it accredited at TSSCI. So that service has been extremely successful over the last few years, but we've gotten obviously additional requirements for secret in the last year. Of course, we fight mainly on SIPRNet. That's where most of our fight occurs, and of course, there's a lot of, from a data analytics and correlation perspective, a lot of that happens on secret. So in November, we are launching the Amazon Secret region. That will come online, and again, just like the TSSCI region, it will be primarily connected to SIPRNet, and then the TSSCI is obviously primarily connected to JWICS, but we'll also be able to connect any secret or TSSCI networks to those individual regions. For example, on the TSSCI region, we have other TS networks going in there. So obviously there's certain agencies and certain missions, special access programs where you do not want your data connected with JWICS. You want it, you're running on an isolated network. Of course, you still have government crypto doing the bulk encryption, and of course you're protecting your data at rest with your own crypto material. But secret's going to be the same way. You can bring many different types of secret networks into the region, not just SIPRNet. So to get into some of the lessons learned real fast. So about 18 months ago, Amazon created a capability that Dwayne has been talking about called Snowball. Snowball is a storage device that weighs about 45 pounds. It's ruggedized to military spec. The first version of Snowball was actually 80 terabytes, and there was actually a 50 terabyte version, and it had no compute on it. It was just storage. And the primary use case was just to get a lot of data into the cloud very quickly from disconnected, environments, or environments where, obviously, if you're trying to move more than 5 terabytes of data over a network, that can take many, many weeks. With a Snowball, you can get 5 terabytes, or in this case, 100 terabytes from one part of the world to the other in a matter of days. And of course, you're not dealing with the physics problem, the speed of light, trying to move data across the continent or across oceans on fiber lines. So Snowball was a storage capability, was great, but what we did, and when the Cyber Command mission came along, we saw a requirement for compute at the edge, right? And it's one thing to have storage and be able to move a lot of data back and forth from across the country or other parts of the country, but you also want to have cloud services out on the edge, right? You want to have data analytics capabilities, packet processing capabilities, and so we deployed a new version of Snowball that actually has compute on it, and that's what the Cyber Command cyber protection teams used over the last 6 months. And from a lessons learned perspective, working with Tim and his team, and he'll jump into some of the stuff they specifically built on top of Amazon, but we learned a lot from the Cyber Command mission, and that's what we loved, that customer feedback. Over a 3.5-month period, we updated firmware, software, and hardware components in the Snowball in real time, based off of real-time feedback from the guys on the ground. So we actually updated the web services, updated the hardware, made it more performant for some situations, made it more resilient to other types of environments, and actually improved the service. And of course, the beauty of any cloud service is that you're not buying hardware up front from Amazon. The way the service actually works is you You go into the Amazon console or through our APIs or command line interface, you order a snowball, we ship it to you, and when you're done with the snowball, you ship it back. It costs $200 for the service. You're not buying the snowball hardware from us. So as we update the hardware and the software, and you order new snowballs, you're automatically getting the latest upgrades without paying anything extra. And in fact, that's the same way all of our cloud services work. We upgrade in place, and the government never has to pay for any of these upgrades. You're just buying the service, whatever it's a dollar a gigabyte or 5 cents a gigabyte, or for compute hour, it might be 10 cents, or it might be $1 or 50 cents, whatever you're buying, right? And then one last capability I wanted to hit upon, kind of a lesson learned. So as Wayne said, a lot of the work we've been doing so far in the cyber community has been mainly on Nipper and Unclass. Amazon, we've had physical circuits running into DRAN and NipperNet for 3 years. We've worked with DISA, connected to the cloud access points, and then we have other physically diverse fiber circuits into NipperNet at DoD points of presence around the country. But a lot of the work we've been doing has been constrained to NipperNet. Last month, we released an Amazon operated certified cross-domain solution. So now we can actually move data from our low-side unclassified Amazon regions right now to the TSSCI network, and then this November when our secret region goes online, you'll be able to move data up to secret. So right now it's a one-way transfer service. You can move objects automatically, that meet predefined rules and requirements, so that as you do analysis on data on Unclass and you start having outputs that you want to start moving up to the high side, you can do that in an automated manner. And this is probably the cheapest, quickest, most effective CDS solution you'll see out there in the government. We're charging less than 95 cents per gigabyte of data transfer from low to high. And then the mean time of moving data from low to high is about 3 to 5 minutes on average. So in 3 to 5 minutes, you can automatically move a data set from low side to high side. And that's, like I said, it's available for our TSSCI environment now, and then it'll go online with secret in November. So yeah, I think I'll turn it over to Tim to talk about the actual stuff they built on AWS.
Sure. So I want to take a second and just kind of rewind and talk about the BDP for just a minute. When you think about the data that you're collecting, right, the data that you're collecting for the purposes of your DCO missions and that sort of thing, the volume of data that you have to process, if you're doing it correctly, is huge, right? It's unmanageable in existing systems, and so the partnership amongst all of the mission partners is a really important one. It's provided a way for DISA and Army Cyber and Cybercom to use the same platform, right, to process and store and query all the data that they choose to ingest, right? So therein comes your next problem, right? How are you ingesting all of this data? How are you managing the life cycle of that data? Well, lots of times what we find is that our end users don't know how much they want to ingest at acquisition time, right? So if you were deploying this on premise, think about your hardware acquisition life cycles, right? Well, 1 year, 1.5 years maybe before it ends up in your data centers and connected. And then what happens if the volume of data that you actually need to collect to serve your mission changes? The way we solve that is with Amazon, right? So if you look at this diagram, you'll see BDPs listed there. You'll also see RADMFs. RADMF was created by us to enable mission partners to put their BDPs inside of Amazon while simultaneously maintaining the security posture. Anyone can take these open source components and put them into Amazon, but a lot of effort goes into maintaining the security posture of the system. It is the reason why Army Cyber and Cybercom can have ATOs inside of Amazon with reciprocity from DISA for their BDP, because the hardware BDP is indistinguishable from one that's in Amazon. So let's blow that out a little bit, right? You've heard about the need to be able to process data on SIPR and the secret regions that are coming, right? You've heard about the need to move data from low to high to correlate the result sets that you're finding on these various systems. But let's talk a little bit about what it means to go through the edge nodes, right? What does it mean to be able to process data at the edge? Right now, what we've been talking about is a form factor which enables you to send your data back to a centralized BDP. Having one at the tactical edge, so let's talk about a smaller version of the BDP, for example. Having one at the tactical edge provides insights at a lower level and faster, right? So instead of maybe a week or two or a few days, you're talking about a day or two, right? What if we could reduce that time even further and provide people with BDP on a laptop, right? So what if we could use that? What would that do for the people that are serving their missions and collecting data in real time? What that does is it reduces time to insight. If we tie that all back together and bring it back up a level and talk about distributed query, what that means is that you can simultaneously process data at the very edge of your collection site. You can process data somewhere in the middle, right? And you can process data centrally, and you can have users who want to aggregate, who want to see what is happening over in mission site 1 or mission site 2 or so on and so forth, and they will then be able to identify behavior and track it, as Dwayne said, through the various regions, right? The snowball is a critical piece of this, I feel. So moving data back and forth is difficult, and so adding compute to it was a huge win for so many. Processing, currently, the snowballs have the ability to do Lambda functions, and it enables people to run compute functions in real time on their data. So streaming data through, getting inside out, finding potentially bad actors or maybe indicators that we then ship up to the high side, right, for further correlation and analysis. In terms of processing, right, when we start thinking about the snowballs further, and I wish we had one to show you, the really cool thing about this is the ability to say, have a set of data come in and maybe display on the screen for you to see in real time. Let me see here.
Jim, can you talk a little bit about the edge nodes and
Yeah.
where they are and what that really means as far as getting data from sort of the edge?
Yeah. Yeah, so a couple things, and Tim brought up a great point. So as we keep iterating on the snowball is something that you can deploy out into a tactical operations center or a remote location. It could work in a disconnected environment. But Amazon also has 70 plus edge nodes deployed across the globe, connected to our global network. We have a global network. It's very, very, very large. It interconnects all Amazon services and regions and edge nodes across the globe. So there's a couple of things we're exploring. Number one, on the disconnected environment, what Tim was getting to is doing analytics in real time at the point of sensor collection. We're enabling more cluster capabilities for those snowball devices, number one. And then those snowball devices actually have Kindles on them, so you can do visualization, or you could hook a laptop into the snowball cluster, either whatever you're more comfortable with, but you could literally, with the Kindle interface right on the snowball, you could actually pull up a web browser, and in real time you could see a Kibana-like interface. That's something that's going to be enabled in the future. But then when you get to the edge nodes, which are connected to our global network, they provide a couple of capabilities. Number one, they provide transfer acceleration for data upload. So if you're somewhere on the other side of the world and you need to get access to our fiber backbone, you could actually upload data encrypted to one of those edge nodes, and then we can move that data back to the United States or somewhere else. But more importantly, you could also take data from the BDPs or from other data sources from the United States and then push those out to the edge, kind of like a content delivery network like that you see out there commercially. The other thing we're looking at doing is enabling this, not just the edge nodes, right, But also the snowballs, we're looking at, deploying machine learning models to the forward edge, right? So now we're getting to using artificial intelligence and machine learning for behavioral analytics and some other interesting use cases. So, yeah, that's kind of the future state of where we're heading.
So, at the end of the day, you look at what the objective of this is, right? Soft voice, right? So at the end of the day, you look at what the objective is, right? The objective for us for the last 4 or 5 years is making sure we're trying to keep pace with our adversaries, making sure we're trying to stay ahead of them, or at least deliver solutions that give our cyber protection teams, our cyber protection brigades, and cyber mission forces the tools that they need to fight the battle or take the battle to our adversary, right? The only way we're able to do this is through the partnership of our government and industry partners, for lack of a better term. We work really well within Army Cyber, within DISA, within MPO, within Cyber Command, and a number of other engagements, and help build out a framework for the community at large, for the industry at large to take advantage of. This wouldn't be possible without these types of relationships from the perspective of just being able to add more brain power, more compute powers, more technological advances on the edge, see how we're adapting, how the enemy is adapting, our adversaries are adapting and pivoting on a dime. As with the last couple of missions we've seen, when they shifted, we were able to shift in a timely manner to make sure we're able to provide those capabilities. What we want to make sure of is we don't want our adversary to be offline by the time we deliver the solution that we needed to deliver 6 months ago for them to capture them. So at the end of the day, between cross-domain solutions, one way, shifting hopefully at some point to a bi-directional cross-domain solution, to being able to share all the information from the analyst, lowering the common denominator, the analyst sitting at the desk, straight out of boot camp, straight out of AIT, to be able to build analytics, to query data, to make them smart, to being able to take the senior analysts and the senior leadership to show what that option looks like as well, is inevitably what we're doing, trying to flatten our domain space to inform decision makers.
Yeah. I think with this, I want to leave some room for questions. And sir, I don't know if you have to straighten us out a little bit up here or anything. Do you feel, and if...
Well, so I'll toss out the first question since you gave me the opportunity.
Yes, sir.
What if I don't want to wait till November? That's 3 months. How do we move further, faster, and fight harder?
Yep.
So we have snowballs available for secret right now. So at least for the tactical edge capability, if you want to get snowballs out there to store classified data as secret or TSSCI, that's available right now. The region building out a hyperscale cloud environment, it does take a little bit of time, but as soon as it comes online in November, it'll be ready to go, sir.
Is that snowball back into C2S right now?
This snowballs are available in C2S right now, yes. Yeah. And they're available for TSSCI and secret data. Yeah.
And the teams support and help integrate, build the analytics, or whatever we need to are available right now as well.
This really has been, the last 6 months especially, has been the prime example of government industry, collaboration, right? This has been, as Sean said, this has been amazing, the ability to, in an agile manner, develop software, iterate on services from industry, take feedback from government and your operational know-how and your operation requirements, feed those operational requirements back into our development lifecycle at Amazon to get new capabilities out to the field quickly. This is the template for where all government industry collaboration should be at. So yeah, we're excited to support your capabilities as secret, and then of course whatever else you need us to deliver, we'll get at that into our roadmap as well.
I would think that was a long answer though, sir, to say the capability is there, and we don't have to wait till November at this point in time.
Yeah.
Anything else, sir? Yeah.
I talk to you guys enough.
Yeah, I know. About 3 years ago, he sort of was the first interface we had with the Army, and I remember very specifically in one of our summits, he said, failure is not an option. And it resonates. I mean, it's been said probably before, but it's sort of never from him to me directly. And so a lot of this stuff is there's no way that any one of us, any one company, any one organization is going to sort of tackle this challenge. This is a community effort. If you look up DevForce, DevForce is DISA's open source community. Again, it's something you should look at only from the standpoint of the amount of community partners, both contractors, the industry, as well as the government, all sort of working into the same vein of develop something once, deploy it many times. And so if you come down to booth 314, we can show you a lot of the things that were built in any one of these use cases, actually sitting on a laptop running, within a laptop sort of framework. It doesn't mean it's going to be the answer, end all, be all, but again, there are at least some ideas here that say that maybe we can look at things a little bit differently. Other questions? Yes, sir.
You use the term data analytics. You use the term data analytics. Include, and where does that occur? Does the user bring that capability, or you provide tools?
Yeah, we provide as part of the BDP, right, there's a number of frameworks that you can use for ingesting data, parsing data, enriching data, and a lot of that fusion can happen at that level, but fusion can also happen at the analytic level, right? So when we talk about what it means to actually join two data sets together and find additional value, right, all of that is built into the BDP as a whole, and lots of mission partners are taking advantage of that to display data, slice and dice data in such a way that is meaningful to that user.
We can also leverage other people bringing their analytics.
That's right.
Do additional data fusing based on their needs.
Right.
Yeah, we prototyped a couple scenarios for CyberQuest where we fused EW data and cyber data as at least an example of how, if all these data sets can be aggregated into an environment, how you could actually start getting some fairly interesting insight across the spectrum of sort of sensors. And so still a lot of work to be done in that. And most of that fusion problem is predicated on those challenges that we talked about at the first two slides, those being met at some level to get these disparate data sets into a place where you can run large-scale analytics to do that fusion and correlation. Yep.
That's fine, sir.
Yeah, just.
One of the lessons learned, you mentioned the need for more sophisticated localized analytics. And Sean, at the tail end, you talked about the analysts themselves. So from your experience, what specialized skill sets do we need for those analysts who are deployed forward that are doing that local ingest and local analysis? And I'm asking from the cyber school perspective because I'm building, those guys are wiggly sat at that second table on the right there.
So there are two components to your question, right? There's the what languages, what specific skill sets do I need to work with raw data, right? And what specific skill sets do I need to slice and dice data? And I would say that the slicing and dicing can be done with BDP tools already, right? So Kibana's in the platform. You could do all sorts of things there. There's a number of different frameworks that allow you to search data and filter data and that sort of thing. Now, for the more sophisticated side of this, what you're talking about is potentially writing a little Java, writing a little Scala, perhaps a little Python, right? Maybe some R and making an R application that will visualize the data in a way that maybe doesn't come out of the box or doesn't exist or hasn't been built by the other mission partners, right? So I would say those are things that you should target, potentially more so on the Java side or Python or R side.
But I think at the same time, though, we look at and discuss the idea of how do you lower that barrier of entry even farther, right? For a scenario, typically what we've seen prior military is your junior guys coming out of AIT can write Python scripts, but how do you pivot a Python script into something like a Spark job or an R job and things like that? So ideally, the lowest common denominator, lowest barrier of entry would be a Python job or some kind of Spark job that someone would be able to write from an entry point at analyst level, right? Inevitably, at some point, we're going to have
solves 80% of their problem and just modify it, right? That's a great place for any junior person to start getting more value out of the data that exists in the system.
Again, going from a open source community, the idea is more eyes that you have on the problem, the quicker we can get to the result, right? So through the data sharing, script sharing, code sharing perspective, the idea would be that the most junior in your scenario could write something relatively quickly, seemingly mildly sophisticated to get an initial answer. And then as we move through the data stack, we could actually refine that with additional senior input.
One of the things that we've seen as a big challenge for all analysts is there's so many tools to use. You know, hundreds of tools, which ones to use. This one says it's better than that one. And I guess if we can figure out how to refine not the ability to build tools, but the basic platform or infrastructure that you're building those tools on, then maybe they become more common as opposed to like 100 different vendors, and I'm not slamming any vendors, I'm just saying 100 different tool sets, and every analyst team is going out and picking the ones that they feel most comfortable with. And while that's, I think, awesome for the mission today, we've got to figure out holistically, back to one of the lessons learned, how do we really structure this at a place where we can start learning these lessons, communicating the lessons learned from all these different places, and then building something just a little bit better than we have today, because it's way too many choices.
The last point I'll make on that one is one of the things we've been a part of CyberQuest for the last 2 years. Each one of those activities we've taken away from working with the analysts. What are they using? What are they expecting to see? What are they asking for, right? So one of the things that in your particular scenario is, what is the common baseline that you have coming into the schools and out of the schools from a training perspective? What is the common barrier of entry? And we can typically pivot or tailor what we're looking at initially or spitball the idea of how do we help bridge the Rubicon of making functional use of their time and ability to write analytics. That, again, if that makes any sense.
No great answer, sir. You know, sorry.
Thank you. It's a good answer. Thank you.
Yeah. Okay.
So I'm not going to have access to that accreditation package, so I'm just wondering if the Amazon Web Services treat government information differently than they treat commercial? Because if it's so globally responsive, I would think that it's a logical isolation, not some sort of physical. But I'm just curious if there's some.
Yeah, typically the security controls, so we accredit using this 853 security controls, and we do when we do our review with DISA and with the FedRAMP program office, we have to show how we meet all those for the security controls. And there's kind of that shared responsibility model. So yeah, to get to the crux of your question, it's mainly logical separation. Physical separation is, wow, that's nice to have, right? It's costly, it doesn't scale very well. And quite frankly, you can get a lot more security protections by using cryptography and having the right systems put in place for data isolation. So our whole model, right, is tenant isolation and zero trust. We wouldn't have a business if we were not able to protect every individual customer's data and keep that data protected from other customers, keep their data protected for Amazon employees, right, and keep our Amazon employees away from your data. We actually have a model in place where Amazon employees are technically prevented from accessing customer data.
Exposure, that picture that you just saw with those edge nodes, those edge nodes are not right now connected to the government region. So that's the work that would have to be done, that connecting of some of those edge nodes within that trusted government region. Because right now they are spread out across the commercial. And while we can encrypt things, you know, it's still a little bit risky sending stuff from overseas, you know that deal. So that's some of the things that we're talking about. The S on the DoD side, because the S that Jim is talking about is on the IC side. And while they should seem like they're the same, they're not for Title 10, Title 50. The S in the DoD still needs to be sponsored and have a contract vehicle at least to provision that S side. So again, some of these things on the picture still need to be sort of worked through, but it's sort of at least a place where we can start talking about how do we get there if in fact we find this as viable. I think that's it. We are at booth 314, so if you want to spend the next 2 days talking about any one or combination of these slides, we're more than happy to do it. Melissa, Melissa is our Cybercom POC, so she can talk to you unclassified about all that Cybercom stuff. And Colonel Stanton is a wealth of knowledge. You're just going to have to find him. But I appreciate you, sir, for joining us. Thank you.
So thank you to Dwayne. Just a reminder, if you want to get your 1 hour credit for the class, please come and see me. The next session here is at 12 o'clock. Oh, I got to make this thing work. Loading, sweeping. That's the line.